Okay, so here's some exponential decay for you, and it's exactly very similar, not exactly, but very similar to exponential growth, which we just did. Except now this time, when we look at our formula, b has to be between 0 and 1 instead of larger than 1. That's the only difference. And what happens is we get a graph that goes upside down instead of right side up, as it were. So remember, your exponential growth, let's not use green, so let's use like purple. Remember, exponential growth started off and did something like this. And so where that happens now, and I'll move him so that he's going through 1. Okay, that's exponential growth. So this guy right here, this is f of x equals b to the x. But in this case, b is greater than 1. Okay? So that guy is growth. The green guy is decay, and he has all the same kind of rules and properties and things that we just worked on. So we can do all of this. It's just going to be it's just going to be a reverse graph, a switched over graph, a flipped graph, however you want to think about it. So if I want to graph some points down here, if I want to graph this guy, then what I've got is, let's make a table of points. So let's let x be some points, and we'll pick an x, and we'll find a y. So let's go like -2, -1, 0, 1, and 2. And we just put these numbers in for x. So when I do that first guy, I'm going to have 1/2 to the -2. This is the same thing as saying 1/2 to the -2, which is 2 squared over 1, which is 4. So this first guy's 4. That's my first point. Then, let's look at the next one. So 1/2 to the -1 is the same thing as 1/2 to the -1, which is the same thing as 2. And then 0. 1/2 to the 0 is the same thing as 1 to the 0 over 2 to the 0, which is 1. And then put a 1 in, so this is 1/2 to the first, which is 1/2. And then put the 2 in, which is going to end up being 1/4. And then just plot these guys out. So at -2, I'm at 4. At -1, I'm at 2. At 0, I'm at 1. At 1, I'm at 1/2, and at 2, I'm at 1/4. And so here is my graph. And if we look at this guy, the domain goes from -infinity to +infinity. Those are the x values that you start at and the x values that you stop at. And then the range on this guy goes from 0 to +infinity for the same thing. 0 is where you start, and infinity is where you stop. Okay, so here let's look at a couple different graphs. Starting with 2 times 1/4 to the x. Notice that x is only on the 1/4. So if I just look at a few points real quick, let's just take a look at when x is -2, when x is -1, when x is 0, when x is 1, and when x is 2. So let's just look at these points real quick. And when I do that, I'm going to have 2 times 1/4 to the -2. That's the same thing as 2 times 1/4 to the -2, which is 2 times 4 squared, which is 32. So for this one, I've got the point -2, 32. And then when I do the negative 1, I've got 2 times 1/4 to the negative 1, which is the same thing as 2 times 1/4 to the negative 1, which is the same thing as 2 times 4, which is 8. So I've got the point -1, 8. And then when I look at x to the 0, then I've got 2 times 1/4 to the 0, which is 2 times 1. So 0, 2. And then I'm going to the positive side of the x-axis, so that's going to be 2 times 1/4 to the first, which is 2 times 1/4, which is a half. And then the next one, the last one, is going to be 2 times 1/4 squared, which is 2 times 1/16, which is 1/8. So if I just plot these points, I'm at -232. That's way, way, way up here. -1, 8. 1, 2, 3, 4, 5, 6, 7, 8. 0, 2. 1 and 1/2. And then 2 and 1/8. So this graph looks something like this. Big decay graph. Big, big decay. Okay? Exponential decay, you may say. And so let's look at this other guy. So we're working on this other guy over here. Again, we can look at those x values where x is equal to -2, -1, 0, 1, and 2. So this is going to be -3 times 2/5 to the -2. And when you do this, you're going to actually flip the 2/5. So you're going to have -3 times 5 squared over 2 squared, which is 25 over 4. So -75 over 4 is one of my points. And then put a 1 in. And when you put that 1 in, you're going to end up with -3 times 2/5 to the -1, which is -3 times 3/2, which is -9/2. So at -1, we're at -9/2. At 0, hopefully you're catching this one, 0 is just going to be -3. And then when I'm at 1, one is going to be -6/5. And then 2 is going to be -12/25. Oop, this should be 25 right here. So this is going to be 2 squared is 4 is -12 over 25. So when you plot those points, you're going to get exponential growth going the other way now. 9/2 is 4.5. So when I'm at -1, I'm at 1, 2, 3, 4.5. And then 75 divided by 4. Let's double check that one. Is about 18 and 3/4. So when I'm at -2, I'm at 18 and 3/4. So way down here. And then at 1, I'm at -6/25. So not very big. And then at 2, I'm at -12/25. Let's see. Even smaller. So here's your graph. Going to look something like this. So since that guy's negative to start with, he's going to be an upside. He's going to just have the he's going to come from the bottom side of the graph. So the domain on this guy goes from -infinity to +infinity because that's where you start and stop. The range is going to go from 0 to infinity because everything's above the x-axis. On the other hand, over here, -infinity to infinity, and then the range goes from 0, -infinity, to 0. Let me graph that. Let me write that a little better. So there's those guys. Okay, so if we're going to graph this problem right here, what we want to do is focus in on the first part of that, which is just going to be, I'll just highlight it right here. We would just want to look at just this part that I've highlighted. We're going to ignore 1 and 2 for now, okay? And so when we do this, we'll just make a quick table of points because, you know, it's going to be not too bad. So we'll have some x coordinates and some y coordinates. I'll draw them a different way this time. I've kind of done a different way on each problem here. And we're going to go with -2, -1, 0, 1, and 2. And at 0, we know it's going to be 3. Okay? And again, this is just for the graph of 3 times 1/2 to the x. This is what we're interested in. So at -2, 3 times 1/2 to the -2. That's the same thing as 3 times 1/2 to the -2, which is the same thing as 3 times 2 squared, which is the same thing as 3 times 4, or 12. Okay? And it's okay if you have to take all those steps until you catch it. Please take all those steps. Show all your steps, and you won't miss the problem. Next up is going to be 3 times 1/2 to the -1, which is the same thing as 3 times 1/2 to the -1, which is the same thing as 3 times 2 to the first, which is 6. And then 3. And then we get on the other side of that equation. And now we're going to look at 3 times 1/2 to the first, which is 3/2. And then we're going to look at 3 times 1/2 squared, which is 3 times 1/4, which is 3/4. So this is what we're going to graph for our parent function. Okay, and it's an easy graph to do. So we're at -2, 12, which is not too bad. It's just right off the screen. -1, 6, 1, 2, 3, 4, 5, 6, 0, 3, 1, 1.5, and then 2 and 3/4. So here's my graph, and when we translate this graph, if you want to come back through and put in a whole new set of points, you can. But the easiest thing to do is to look at this guy. Let's look at this whole guy here. We want to look at all these guys. I want to group all those guys together. We want to look at this whole guy right here. And what we want to do is just move him, okay, from his starting spot, which is, whoa, we don't want to move that guy. Alright, got it fixed here. So what we want to do is take this graph and we want to move the graph in the direction of x that goes opposite of what the number says. So it's a super secret opposite society. So with that x plus 1, that means that we're going to move 1 unit left. And with the 2 right here, that's your y1. So that just that plus 2, that means that we're going to move 2 units up. And so what happens is you take that whole graph and you move 1 unit left. So everything moves 1 unit left. There's 1 unit left. You can see all the little dots line up 1 unit left. And then 2 units up just means we're going to go up 1, 2 units. So up one more time to 2 units right there. And so that's what my graph is going to look like. And it's really, in the long run, a lot easier if you can get to the point where you recognize that this guy moves me up and down exactly what it says, and this guy moves me left and right the opposite of what it says. As soon as you can get comfortable with that, all of your math skills later with any graph that you face will get much, much easier to work with.